record on this computer and upload it later. All right, so Anand has asked a very good question. What sorts of things do you need to take into consideration when you're designing a robot? So robots are usually made up of several big components. One of them is called the robot base. And the robot base generally means the wheels and the motors, right? And so there are a number of different approaches that you can take to robot bases. And so I'm going to show you some CAD models real quick, and then I'll show you where you find this stuff. So, and it'll just show you some options about potential robot bases that you might use. And we'll talk a little bit about the pros and cons of each one of them when it comes to working in FTC. So the first one I'm going to show you by sharing my screen, I'm going to show you the CAD model of something that we call FirstBot. And we'll use Nate's version of it here. So this is Onshape as a CAD program that is available to all anybody who wants to learn how to do CAD. It's free for first people. And so, and it's actually the topic of next week's presentation. So I'm going to be talking about how you can use this. So that'll be in next Tuesday. So
okay. I'm back.
I
do want to learn CAD.
You do want to learn CAD. Outstanding. I'll show you some stuff next week, Karin, about that. So here, this is about as basic a robot base as I can come up with, which is it's just 4 wheels and it's square. So the robot base is square. It has 2 drive wheels in the back, and it has 2 idler wheels in the front. And this style of drive base, you would consider the drive base being the wheels and the frame that sort of holds it together. This is called differential drive, and what that means is that it drives and steers based on differentials between 2 wheels. And so if you put both wheels in forward, it should drive relatively straight forward. If you put one in the right one in forward and the left one in reverse, it'll spin to the left. Vice versa, it'll spin to the right with the left motor going forward and the right motor going backwards, or you can go backwards, okay? This is about as simple as it gets. It doesn't require, it only requires 2 motors. This is a completely serviceable, that's a completely serviceable robot base. In order for it to turn, it's relying on the front wheels up here skidding as it turns. So as this guy rotates, it will these wheels need to slip across the surface of whatever you've got. So if this robot was particularly heavy, for example, the downside to this style of wheelbase is that those front wheels can actually make it really difficult to turn. So it's really great on lightweight robots, but it can be a little difficult to turn. So that, but this is about as basic as you get. The one that we've got here are using stealth wheels from Andy Mark. If you're not aware, there's a company called Andy Mark, andymark.com. And they are based in Kokomo, Indiana. This is the unofficial first store, and one of them. And this is the biggest of the first stores. And you can find all sorts of things on here. So if I go to mechanical and I go over to, we got wheels. And if you look under stealth wheels, that's where I got these wheels. And you can see there's several options. I'm just going to pick a few of the options. We're going to use 4-inch diameter with a, there you go. The durometer here is the stickiness of the wheel. I think our robots are actually using the gray ones. Not too bad. They're pretty durable, pretty sticky. But anyway, this style of wheel gives good traction. So, hello.
So the durometer, So that says like how much it grips to the ground or how much it sticks.
It's
And
how
that's
hard the material is. So if you remember,
plus.
if you remember my those green wheels that I was showing you earlier, these guys, these green wheels have a durometer of 35. So the lower the number, the stickier it is, but also the less durable it is. So a high number.
That's why it bends.
Yeah.
So the higher is the more hard.
And more durable. Yeah.
And more durable. Okay, yeah.
But less sticky.
But less sticky, yes. So so the green ones, the 35 has a very high coefficient of friction with most materials. The 80 has a lower coefficient of friction. These can be damaged relatively easy and are very soft. 80s are much harder. So anyway, going back to this guy, so this is about as simple as it gets. There is another style of wheel. If I open up Autonomous Prime's robot, this is a robot that we used last year in our competition. And here it is. And again, we did this in CAD. And this is a variation on that simple wheelbase that I just showed you.
Build it first in CAD and then actually build it? Usually.
Yeah.
Cool.
And this is the first year that we managed to pull that off, mostly because we couldn't meet in person. So we built the robot virtually. It worked really well. The kids worked on it for a long time. We worked on, we actually got into really designing the robot in, I think, January. And we had been playing around with the CAD program for a month or two. And then we designed, I helped a lot, by the way. So it requires some planning, right? But we actually started building parts in March using a CNC machine, some other stuff that you don't have. Don't worry about it. But we actually met for the first time on April 2nd, and we we put the robot together. I'd never met the kids in person. So April 2nd, they came to my house and we had it up and running on April 6th. So it was pretty fast. Anyway, what I wanted to show you is it's really the same basic thing. You've got the same drive wheels that I just showed you on that other robot. And then on the front, we used a slightly different kind of wheel. And I'm going to zoom in on this guy. And let's see, I guess I want to, how am I going to, let's see, I need to make this transparent. Oop. And I need to make this transparent so you can see this thing.
Yeah, I can see those wheels.
Yeah, you can see the wheels. Those are called Omni Wheels. And they have relative decent.
I remember those wheels.
Do you? Yeah.
In the THS, they did like a summer thing.
Yeah.
Like they do it. And I'm sure you probably know. Well, maybe, because I don't know if you're in the area, but nevertheless, they have like this summer camp for like a week where you design a robot, and those were there. They were like green. In the end, our people used them, and it drifted so much because of the little like black thing. In this case, they're black. It drifts so much just because those are little wheels within the wheel. And I just am not going to, I would recommend not using those. Even though I'm new, I'm going to give some advice.
It depends on the contest that you're doing and what your design parameters are, right? The upside to this is that if you're using this differential thing, these wheels allow the robot to slide sideways, right? So when you go to turn, there's no coefficient of friction in this direction. So these wheels will slide very easily left and right. And so if that's what you need, it's not a bad option. The downside to it is if you have to play defense against another robot, for example, if they come and push on you up here, you're just going to get spun right around, right? In last year's game, we played it solo. We didn't have to worry about defense. This turned out to work out pretty good for us. I don't think I would have used these wheels, particularly with if there's any chance of defense or shoving match. But on the other hand, if you're just building something to drive around, it's not bad. So like Karin is pointing out, there are downsides to these wheels. They have no coefficient of friction in the perpendicular directions, right? So they do fine if you've got a motor on these. They actually do fine going this direction, right? I don't know if that's showing up. So going straight ahead, coefficient of friction is not bad, and they're drivable. So again, just an option, there you go. That's called an Omni wheel, OMNI, and you can find those on. They can be a little expensive. The particular Omni wheels that we're using are from a different company called Tetrix, but Andy Mark sells Omni wheels in various flavors. You can see that these guys are a little expensive. They're $37 each. You can find them less expensive. This is sort of their high-end one, but some of them have fewer rollers. But there you go. Doable and usable. Rev Robotics is the other company that is very commonly used in FTC. They're sort of the premier FTC provider of things, and they also have lots and lots of FTC parts, and it's all broken down, and you can look under motion, and you can find they also have their version of wheels. Sorry, I have to. And so they have an Omni wheel. This is a better price than Andy Mark. You get 2 of these, for example, for about $25. It's a pretty decent price. There you go. I should probably be fair and point out that I am part owner of Andy Mark. I don't, just so I'm clear, I'm not like trying to hawk my own stuff. I'm a very silent partner in the background. I'm also a customer of Andy Marks. That's why I was an investor. So anyway, I just wanted to be upfront about that. So, but Rev Robotics has got a pretty good price on this sort of stuff. And actually, if you go to our dear friends at Amazon and you look up Omni Wheel Tetrix, these are actually the wheels if they still have them. Oh, they may not have them anymore. Okay, well, there are other sources you can find Omni wheels.
I have to go.
All right, see you later, man.
Thank you.
You can find other sources of Omni wheels and actually all of these wheels. So anyway, so now we've shown you 2 robot bases. These are relatively similar. Let's go with one that is quite a bit different, and that is in this robot, which is another robot that we built for last year's contest. This uses a drive system called a Mecanum drive system, and these are quite a bit more sophisticated to use. They're very cool. They're kind of expensive, but they give you some interesting capabilities. This is a very complicated model. It'll take a second to load. The idea behind a Mecanum wheel is that it allows your robot to travel actually in any direction. So I'm going to flip this guy on his back, and we're going to take a look at these wheels real quick. Okay, so the wheels, these are them here, and you can see they're made up of rollers. And to best demonstrate that, I'm just going to go grab another set of Mecanum wheels just so I can zoom in and show you what they look like. So this is a style. Actually, they have a better one up here. Let me see where their new Mecanum wheels. All right, well, we're just going to go with this for now. Actually, the ones that I'm using are from Go Builda. Go Builda is yet another company. They have motion, and you can find, well, their Mecanum wheels are right there on the front page. See those? sorry, I'm scrolling through this really fast trying to find it. Anyway, these wheels can be driven in any direction because, here we go, these rollers sit at a 45-degree angle. And so when you go to drive the robots, if you put all 4 wheels in motion, the left side wheels are going to push the robot to, or I'm sorry, right side wheels will push the robot to the left. The left side will push them to the right. And those forces will oppose each other and the robot will actually end up going straight. The cool thing is that this robot can actually drive in any direction. So depending on how you program these, this robot can either drive straight, which is to the right here in the X direction. It can also drive backwards. It can also drive in the Y direction. So it can drive sideways. It can also actually do something called a strafe, which is sort of a hybrid between the two. So you can actually move it in any direction. Very cool, rather complicated to program. But otherwise is actually a pretty cool and useful thing to do. So
how do you choose like to use mechanism versus?
I joined back.
Welcome back, Karan. So Anand, you asked a very good question. Why would I choose one over the other? A super great question. Part of it is cost. And part of it is actually, quite frankly, the gain. It turns out that the wheels that have these roller mechanisms on them, they tend to not work super great if you're on a ramp. If you have to drive over something uneven, they don't steer all that well in those situations. And because they're working on opposing forces. So these are really great if you're always going to be flat on the floor. Right. And need high maneuverability. Downside to these wheels is just like the Omni wheels, they don't hold positions terribly well if somebody pushes on you. They're not bad, but they don't. If you had just the fixed wheels, if somebody pushes on you from the side, it's super hard to get you to move. These guys, you know, even if the wheels are all locked up, you can actually get all of those wheels to move. So there's some of the trade-offs. The other trade-offs are each one of these wheels needs to be driven by its own motor because you'll need to be able to control each of these motors so that they run in different directions depending on what you want to do. So it requires 4 motors to run these. And you can see what Alex did here is, let's see if I can rotate this around. You can see that the rear wheels here are directly coupled to the drive motors, these drive motors. So the rear wheels on this robot are directly driven, and then the front wheels are driven by this motor here with a belt. And the reason for that was he needed room up here for other mechanisms. So again, it requires 4 motors, takes a lot of room. It also uses up all of the motor ports on one of your Rev Robotics control hubs.
So this robot is using like 2 of those hubs, driver hubs or control hubs.
These things?
Yeah.
Yeah. Well, he's got, because he has the drive motors for the base, there are 4 motors.
Right.
So he has allocated all of the motor ports on this control board just to drive the robot base. The mechanisms, like his intake mechanism, uses this motor. And if I spin this around, he has another motor up here that runs a different part of the intake mechanism. And then he has 2 more large motors that run his shooter for shooting the rings from this game. So he's actually using 8 motors. Wow. And that requires him to use a control hub and an expansion hub.
I see.
And you're allowed to do that. And they actually, these communicate with an RS-485 connection. So they have a private little network that they run on. So you really actually only talk to one of them and program one of them, and the other one's used as a slave. Does that make sense?
Yeah.
Yeah. And you can have up to 2 of these modules on your robot, and it's
So one control hub and one expansion hub. So
yeah, yep.
Explain two. Okay.
Yeah, and then what that did is it gave him another on here. So the control hub controls 4 DC motors, and then it'll control 5 servo motors, and then it has a set of analog to digital channels and some digital channels, and then some other communication stuff. And so by having 2 of these, he's actually able to use 10 servo motors and lots more switches. He didn't actually use all that many servos, but you can actually load up on a lot of servos here. Okay.
Yeah, it looks amazing.
Yeah, this is high end. This is a very high end robot. If this is your first year, don't worry about it. This is his 4th year, and we have sort of a mechanical savant on our team. And he had a lot of time to work on this. And it's one of the highest ranked teams in the country. It's a really good robot. So that it's not really something that we would expect out of a rookie team, honestly. So, all right. So anyway, so a Mecanum drive base is not bad. I think that it is cool. There's no doubt about it. And the students think it's cool, but it does take a little bit of finagling to get it to work well for you. How am I doing?
Yeah,
got one more drive base to show you. You ready?
Oh, cool. Yeah.
Okay. And I don't have a CAD model of one, so I'm going to show you. I'm going to show you one that has been pre-built by Andy Mark. And you could buy one, or I would highly recommend building your own. I know that my company sells them. So, but we really sell these things for ideally to be used in classrooms rather than for competitions, but they are competition legal. It's called a tile runner. And so a tile runner is a 6-wheel or is configurable. Okay, so drive style, we want to have 6-wheel drive. And we are going to use, we'll use 68 compliant wheels. They're allowing us to build one here. And we'll use orbital 20 motors and a gearbox. Okay, so I'm not sure whether it's actually going to update the picture. It didn't. Okay, so let me go back and find a better picture of a tile runner. Actually, it's called West Coast First Drive. We'll look at this on. This may make more sense. This is an FRC robot, but it works kind of the same. So this is what a West Coast Drive looks like. And I don't know if this is a good one. Oh, they used an 8-wheel drive. Okay, so this is another option, which is to have 6 or 8 wheels, and then you sort of chain them together. So this acts as a unit and that acts as a unit. The center wheels are actually dropped down just a little bit, like maybe a 1/4 inch or so. So the robot is actually sitting on the center wheels, and the outrigger wheels are there just to provide stability. And you can see that they actually used Omni Wheels out here. That's how this team chose to implement it. Another one is to just use 6 wheels. And so let me go find a 6-wheel drive West Coast Drive. Does somebody else have West Coast Drive? And you can do the same thing in FTC West Coast Drive. Let's see who. Usually you'll find this with 6 wheels. Here's one. Oh, come on. Okay, well, so you can kind of see down here, they've got 6 wheels. The center one, again, is usually dropped a little bit. And these are really good if you need to push on somebody or if you feel like you're going to get defended on. They're really good. They give you really pretty strong traction. They're really good at driving over stuff. So if you have to go up and over ramps, you get good ground clearance with these. So it's actually a completely legit and way to build a robot base, and it just sort of depends on the game. If I had to go up and over ramps, or if I had to do some heavy pushing, or we think that that teams will be playing defense and kind of going head to head a little bit more, a really good option for that. It just uses those.
Like, does it change every year, or usually you have to defend? Like,
Depends on the game for the year. In FRC, so this is an FRC, well, actually, this is an FTC robot. FRC tends to allow more pushing on each other. FTC, usually the games aren't really designed for that. It's still legal to oftentimes it is legal to block somebody from doing something. So it is a possibility. We'll find out on Saturday about the specifics of this game. But usually FTC the game isn't really designed to be heavy defense. And a lot of times there are penalties from pinning people or pushing too much. It really isn't designed to, we don't really play that way in FTC, although it is sometimes legal. Depends on the game. Wishy-washy answer because I don't know the answer for this year.
Yeah.
Okay, so but these 6-wheel designs super common in FRC. They are somewhat common in FTC as well, although not quite as often because a lot of times the game isn't there. So this is another kind of drive system you may hear about. This is, oh, it just went fuzzy on me. This is something, there's several different terms for it. One of them is Holonomic Drive, and it's kind of along the same theory as the Mecanum design, but it uses Omni Wheels. And you can see the wheels are actually positioned at 45-degree angles. So it's really Mecanum Drive, but using Omni Wheels instead. And so it's the same basic idea. You've got opposing forces here. So in order, and you should be able to drive in any direction. And again, it uses the 4 motors, and you rely on the fact that when all of the wheels are turning a specific direction, the funny forces cancel each other out, and you end up going forward. Does that make sense?
Yep.
Yeah, and you can see this guy drive around. This is a not very good quality video, but you can see they can drive that. They can drive any direction. They can also, you can see they're actually driving on diagonals. Wow. And they can spin around. So these are really highly maneuverable. It's a completely reasonable design choice depending on what you needed to do. And you can even drive while spinning. It's cool stuff. And it's, they've been around a long time. My team did this, one of my teams did this about 3 years ago. They ended up using this based on the game that that came out. So
how difficult it is to program?
Not too bad. You can find examples. And you have to learn a little bit about vector math, because that's usually the best way to do it is to figure out what the resulting vector is by adding, if you add the vectors from like the left and right wheel together, that you will end up with the direction that you're actually going to go if you do the math, and then you can actually back translate that into code. Not too bad. There are good examples on the internet you can find. Yeah. Okay, so we had differential drive using static wheels. We had differential drive using Omni Wheels. We had Mecanum wheels, which are the four Mecanum wheels.
Right.
The ancillary to that was what we just saw, which is oftentimes called Holonomic Drive. There are a couple of other terms for it. They also angled. You'll find a bunch of different terms. There's no official term for it. And then there's the 6-wheel. It's often called West Coast Drive. And a good way to think about it is it works very similar to a Home Depot lumber cart. You know how it's got the big wheel in the center and then the caster wheels on the front and the back. It's the same sort of idea. You're trying to rest most of the weight in the center of the robot on the center wheels, and the outer wheels, while they're still powered and can help drive over stuff, when you're just driving level, you're hoping that the robot's balanced enough that it actually, very maneuverable, by the way. They spin very nicely, usually.
Yeah, this was like really informative.
Oh, I'm so glad. I'm so glad. Let's talk just for a second about the motors that drive this stuff. Did you get a Rev Robotics kit, Anand, or what kind of kit did you get?
We got a Go Build a kit.
You got to go build a kit. Great. Yeah. Good company. So let's see, you got one of these?
Yeah.
Yeah. Okay. So I'm just going to take a peek. I admit I don't remember off the top of my head. Yeah. Okay. So these come with very reasonable motors. They're a 20-to-1 gear ratio, which allows you to get some pretty good speed out of it. And for driving, they're great. So good choice. These have the D-Hub. Okay, so on the back side of them, you should be able to plug in an encoder. That is a sensor that tells you how fast or how this guy is rotating. So it basically, as it rotates, it'll give you a certain number of clicks per revolution. It's a lot of clicks. It turns out should be somewhere around 1,120 clicks per second or per revolution. So you can actually do some pretty precise measuring of things, and that'll help tell you how far you've gone. It can also, if you're doing it on a regular time interval, it can tell you how fast you're going. And the motor classes will also, you can use in software, you can set up the encoders and you can say encoders drive to 3,000 clicks that way. And the robot will automatically move to 3,000 clicks and stop. And it'll actually hold its position there unless you tell it to do something else. So it's actually a nice way to navigate if you need to. So, this is a great choice of motors. There are options for motors. You can change the gear ratios. So the motor and the encoder are actually different than the gear head that goes on it. And so you can replace the gear head with the same motor. So you'll find there are many options for these. And so if I look on Go Build It, for example, and I go to motion and I look under motors, the yellow jackets it's a great motor. They work great. I'm always very impressed by them. And they have several options that you can get. So if I look on here, you probably got, so they have the 5202s. I don't know which one you've got. They have
52.
You got the 03s?
Yeah.
So they have a hex shaft?
Yeah.
Yep. Oh, good. All right. So you can get different gear ratios, and I think, yeah. Okay. So the way their part numbering system works is that there's the base, and then the last 4 digits tell you the gear ratio of the motors. And so you have 19-to-1s, comes with a default kit. So it tells you that without a load on it, it turns about 312 RPM. Great. You can get different gear ratios of those motors all the way up to 188, and it'll do about 30 RPM. In other words, it'll take 2 seconds to make a 2 seconds to make a full revolution, which is pretty slow, and it's really quite strong.
Yeah, it has more torque, so it's
yep, more torque or low speed. Yeah. So so you've got some options there, and I think for your drive base, I think I would go with the 19:1 gear ratio. It's actually something crazy like 19.3 or 19. Anyway, a lot of people just round it up to 20 just because the math is easier. So we call it a 20:1. You can get very similar motors to that from like Andy Mark, for example. They have these motors, which are it's basically the same motor. It's got very, very similar encoder stuff on the back. They cost a little bit less, but they have a D shaft for the output is the only downside to them. So 601, half dozen the other kind of. These guys are a little more expensive at $40 each. I end up buying like 50 or 60 of these a year because I have a lot of teams. And so the $10 actually matters to us. So yeah. All right. So that would sort of inform what I think that we have found that the 20:1s on a 4-inch wheel are actually just slightly too fast. And the 20:1 on a 3-inch wheel is really nice. So somewhere between a 3 and a 4-inch wheel. Again, it depends on the game and how much room that we have to work with. There are times where you can actually drive your robot way the heck too fast.
So like in like EV3 kit, right? You can control the speed of the motor, right?
Yes.
So, very basic question, like can you control the speed of these motors as well?
Mm-hmm. You can, because you will be using this control hub. I'll switch over here. Stop sharing my screen for a sec. So a control hub like this, and each one of these motor ports has a couple of nice features. I'm just going to zoom this in, I think. Can I zoom it in? Let's see what happens. All right. So each motor port, wow, that's really dark. Hang on a second, I'm going to bring over another light. Each one of these motor ports has a control port. So this is it's attached to a H-bridge if you're an engineer, which means that you can flip the polarity, make the motor go forward and backward, and also pulse width modulate the current to adjust the amount of current that the motor gets, which sort of roughly turns into how fast the motor is going to turn. The other thing right next to it is a connection for the shaft encoders. I was telling you the back of the motors of these motors all have shaft encoders that will allow you to know, like I said, it's about 1,020 clicks per revolution.
Get more feedback about how the motor is doing, right?
Yeah, it's feedback. Yep. And it allows you to do PID. I don't know if you're familiar with that, but it's yep. So the motor class in software actually has PID built right in. So you're able to rely on PID algorithms a lot. And we all use them quite a bit. So so each one of these things has four connections for these large DC motors, for these large DC motors with the encoders on them. And I'm going to grab one of these. So this one is called a control hub. This has the equivalent of a cell phone built into it. And can do Wi-Fi. Its companion is called an expansion hub, and the physically they're identical except for the back the back here. This one has like an HDMI port and some bunch of USB connections and stuff, and it even has a micro SD slot. This one has this really crappy USB mini connector, one of the old mini connectors. And but this guy here is set up to be the controller, and this is sort of an expansion for it. But in prior years, this didn't exist, and we used this expansion hub, and you connect it via USB to a cell phone. Now, I believe you should have one of these. Yeah. You can buy extra ones of these, and if you're planning on making any sort of really sophisticated robot with more than 4 of these motors, you'll need one of these.
Right.
In general, I would tell you that if you think there's any chance you're going to do Mecanum drives, you need to get an expansion hub because you're going to use up all of your motors on this. You can only put 1 motor per connection.
Right.
Okay. Make sense?
Yep.
Yeah. And so so that's kind of what that's kind of the difference between a control hub and an expansion hub. And I think that this is the best thing to happen to FTC in a long time. This control. It's
better than the cell phone thing.
The cell phone thing was fun. And I still actually use the cell phones because I don't have enough control hubs yet. The cell phone thing was a huge step forward in technology because we were based on the NXT, the Lego NXT controller, which we had all kinds of problems. It was done using Bluetooth. It was awful. We had tons of problems. So then we moved forward to cell phones using another box somewhat similar to this that had all kinds of quality control problems and was really static sensitive, and we had bad juju on that. Then we came out. First came out with these with this expansion hub and control hub idea, and that actually worked out really well. Well, the expansion hub did, but the downside of the expansion hub was that stupid USB mini connector. It's not a micro, and it just was not designed to do what we were doing with it, because it's a terrible connector. It doesn't handle side forces, and it jiggled and would lose connection all the time. So now we've got, and then the problem became that the cell phones that we were using, we couldn't reliably get them year after year. Every year, the phone companies would come up with a new cell phone, and sure enough, something would be incompatible with the USB, with the Wi-Fi Direct. It was hard to get. Android is a very portable operating system in theory. In practice, it's not compatible. Every manufacturer does their own things, and so we were stuck to one specific model of phone for a while, the Motorola E series, and the E4 worked good, the E5 worked good, the E6 doesn't work. So we got rid of, and hey, the cell phone companies are constantly improving, and they don't continually make old products. So, so now we have the control hub has the control hub has the same guts as a cell phone built in, runs Android, and so we can program it. It's just like a cell phone. It doesn't have a screen on it. And even the new, they have a new gadget called the driver station. And we have one. It's actually at my school at the moment.
We got one as well. The driver.
Oh, you did?
Yeah.
Oh, yeah. So you're all set. So we have custom hardware, and all of this stuff is tested, and it works, and it's stable, and we will be able to use it for years. Okay. There was
one question. Like, there are so many types of different kits that you have, right? So we bought the Go Builder, but there is like Rave, Andimar, right? Tetrix. So how compatible are they with one another? Like, can we mix and match the parts?
Yeah. Generally, you can mix and mix and match most parts. They all sort of use very similar bolt patterns. They all use, they're not always identical, but there's usually some adapter if you need. Usually I kind of go with one and stick with one. If you remember my, let me bring my screen back up again. So if you remember, just to show you how, so we have Rev Robotic servos. These are Andy Mark motors that we're using here. So these are Never Rest 20s that we're using. We're using Go Builda Mecanum wheels. We're using, these are Go Builda motors because they had a 1-to-1 gear ratio available, and because we needed these to spin really fast. The servo motors are from Rev Robotics. We have learned over the years when you can and can't rely on servo motors for some things. And servo motors are very strong, but are very mechanic. They generate a great deal of torque, but they're mechanically unstable. And so we ended up using these parts, which are from Servo City. So let me bring up Servo City real quick. So Servo City, who also sell Go Builda stuff, by the way, makes these little contraptions that will help you support things. For example, they've moved them. Give me a second. Oh, they're called servo blocks. So a lot of times you can get away with just using a servo with a thing on it. The reality is that sometimes what you need to do is you have the servo, but you really kind of need to support a shaft on both ends with a couple of bearings, because the servo bearing inside is not very big and not very durable, and it's real easy to actually break the servo off. So this little contraption is a mount, and it supports the servo. It's designed to, I'm looking for a good side view of it. So there we go. So the servo output shaft is right behind that thing. And they put in a secondary bearing out here. And so now you've got a secondary bearing that takes most of the load. Instead of putting all the load on that little tiny servo, it's actually on this bearing now. So
if you have like weight from side, right? Not.
Yeah. So if you have a big side load, good thing to use.
I see.
Yeah, and it comes. It comes in. Okay. I don't remember what I'm showing you at the moment. Can you see my thing that I got in my hand here?
Yes.
You may want to stop your screen share if you want us to see it a bit better.
Thank you. I appreciate that. So this whole thing comes as a little kit, and it's nice machined aluminum parts, and yeah, and so these aren't too bad. They're about $30, but nobody said robotics was cheap. But we've actually put some fairly big loads on servo motors using these, and it works pretty good. Especially if you have something that's on a long arm or something like that. I highly recommend doing something like this. There are limits. I mean, servos are not really designed to generate enormous torque, and honestly, what normally will get you with that is if I had, for example, a servo motor with an arm on it, or like, I'll use these calipers, for example. Say I put a servo motor on this caliper so that it moves up and down like this, right? Yeah. the servo may be able to do this without any trouble at all. However, if it's holding position and you run into the wall and you bang it, that's usually what ends up breaking the internals of a servo motor. So there are big limits to what you can actually do to a servo motor, and they really don't handle overstress very well. And so my teams, of course, did that one year. So they all had arms on the ends of servo motors, and every time they hit a wall, they would break the internal gears off the servo. And so we went through literally 20 or 30 servos in the course of a competition once, because they didn't have time to change their mechanism. So it was a one-shot deal. And then inevitably somebody would run into the robot and break that thing.
If you are using servo motors, then make them easy to remove and put back, right?
How much longer do you think we'll be here? My dad assigned me to do a couple things.
No worries, Karn. If you need to take off, we're good. My apologies about.
It just depends. Like, how much longer do you think we would be here if we like stayed to the end?
15 minutes.
Okay.
How about that? Okay.
Sure.
So yeah, and Colin, my apologies about the Git thing. I know that Mike, he did warn me that there was a possibility he would be delayed, and that's what happened. So if we'll reschedule the GitHub part of this for later. So it's all good. We're all volunteers. So Anand, so yeah, so far we've seen GoBuilda, great place to find stuff. Rev Robotics and AndyMark, all great companies. They're really geared towards servicing first customers. AndyMark, that's 75% of the business is dealing with first customers. Rev is closer to 100. I mean, and GoBuilda and all these companies, and they usually have pretty decent reputations. So those are sort of the three big ones in the FTC world. AndyMark is kind of the unofficial first store, if you will, and First uses them a lot for supplying, if you wanted to buy a field, AndyMark is the one that sells the field, makes and sells the field, and they take their first mission very, very seriously. They're all almost the entire staff are first alumni and mentors. So good folks. And Rev Robotics, same way, all first alumni. I don't know the GoBuilda guys. I'm sure that they're probably first people as well. I just haven't had the opportunity to meet them yet. But I know the Rev Robotics guys and the Vex people. I mean, it's a good group of folks. So let's see, what else was I going to show you? So we were talking about your robot base, and so I'm going to go back to GoBuilda. I just wanted to look at one more thing that was in your kit. All right. Oh yeah, so they gave you some servo motors, awesome, and they give you the programmer. I believe their servo motors can be put into a mode that allows them to be positional or continuous rotation. So normally, most servos that you would buy, like from a hobby airplane supply or something like that, they'll only go 180 degrees. This new phase of these servo motors, a lot of them can either do that, and they'll actually allow you to go 359 degrees, or you can also put them in a mode where they do continuous rotation, and they become a very nice small gearhead motor that you can use in contraptions. So I think that's actually pretty cool. Oh, it looks like they may have given you servo mounts. Look at that.
Oh, cool. Oh, this is what they're used for. Yeah.
Yeah, this is what's in your kit. Again, I hadn't actually looked at their kit offering this year, so that's why I was just going to take a peek to see what you guys already have. So there you go. And then these are for attaching to 25 tooth servo motors. So by the way, servo motors come in two flavors. they have metal output shafts, and they're usually 25 tooth. And you can see here that that's the 25 2. That means that's their number of teeth. And so the matching splined parts, you need to make sure if you're ordering servo parts that you're paying attention to the number of teeth, because they do not interchange. If you buy like a Futaba servo for an RC car or something like that, a lot of times they are 24 tooth, and you'll be very disappointed. So anyway, so that's cool. So they've given you some ways to attach. You can get, they're using, so these are 8mm bore. Oh, okay. So if you need, you can actually buy a thing called a broach that'll allow you to drill a hole and make the hex thing in it. You'll need to figure out what size it is. This is an 8mm one, this hex. So that's pretty cool. We have yet to figure out where to buy a reasonably priced spline for servo motors. So don't bother looking. We've been looking for a while. They cost thousands of dollars actually. So most places don't have them. So, but I'm looking through this. You have a very, very nice assortment of parts here. Good. Their gears are a little, well, before I say anything bad, let's go look. Their gears, are those, they're steel, $10. Okay. Not as atrocious as they used to be. Good. I'm glad they brought their prices down. Their gears used to be really quite expensive. This is for a pack of 2, I think. $14.99 for an aluminum 100 tooth. That's not bad, especially if it's a pack of 2. I think it is a pack of 2. Oh, actually, no, that's per. Okay, you got 2 of them in your kit. All right, so $15 for a gear like that is not bad. And they have lots of different attachment options for it. So yeah, good. Outstanding. So I like the kit that you got. Like I said, I hadn't looked. Looks like you've got Omni Wheels.
Yeah.
All right. Awesome. And they gave you some traction wheels, even better. And they've given you 3-inch and 4-inch. So awesome. Their Gecko wheels are pretty good. As I recall, they're compliant and pretty grippy. So that's awesome. This looks like a really nice kit. And they've given you all of the goodies and stuff. All right. Yay.
So when we are using the OnCAD program, right?
Onshape.
Yeah. Is there a way to say that, okay, use materials from this particular kit?
Right. So you can look to see if anybody has uploaded the full kit. Let's go pick on one of those gears. Actually, let's pick on a wheel. Let's go with we'll use an Omni wheel because that's a complicated one. And if I go to the Go Build a Omni wheel page, I'm looking at it, and it turns out I can download a step file. This step file is the CAD format. Step is a CAD format. So I'm going to actually download that, and you didn't see it, but it downloaded over here. And so I'm going to extract that real quick. And so here is a step file for that. And what I can do is I'm going to actually import this into my CAD program. So I'm just going to go back up here. I'm going to go to, I'm making this up as I go because I have not done this with Go Build It yet, although it looks like somebody on my team did. Oh, they did. Okay. But not the Omni wheel. So here's how you do that is you would go, oh, I would like to import a file. And I'm going to go to my downloads here, and I'm going to import that step file. And I'm going to import it as a composite part. Hit OK. And in theory, so it's importing, it needs to translate it. It was uploaded successfully. It's still importing. Go team, there it goes. All right. So now I should be able to open this thing. And there it is. There's the wheel.
Cool. Okay.
Not too bad, right?
Yeah.
And if you needed the hub to go with it, you can probably go find, we'll use one of their hyper hubs. It has a hex bore with appropriate thing. So let's go with the 5mm bore. Why not? And again, they usually will allow you to download a step file. So here comes the step file, and I will I just did the extract in another window. You didn't see it, but now I should be able to come up here and back up one and import a hub, import oh, I see what I did wrong. I now need to import 1310. Here it is. And so you kind of need to like keep these. So next week, I'm going to be talking about CAD, by the way, about this CAD program, give you an intro to how to organize stuff and kind of what it looks like, how to use it. This is free for your students and you, if you'll sign up with an educational account, and it'll allow you to use it for free. And so it's still importing. Go Onshape. It's I really like Onshape. So there's several different CAD programs that you could use. You could use Autodesk Inventor. You can use SolidWorks. You can use Onshape, and there's another one that I can't remember that is also available. So anyway, so here's that hub that I just imported. There it is. So we have access to really good software. There's a little bit of a learning curve on how to actually use it, but from this you can actually put together a pretty robust thing. So I'm just going to go find a random robot. Let's go with. Do I have one in here? No. Well, tell you what. I'm just gonna use this one real quick. Why not?
It's fine. You are going to show this next week, anyways.
I'm going to show this next week.
Yeah.
But so basically the idea is that from Andy Mark, from Rev Robotics, from Go Builda, most all of the parts you can download step files from.
Yeah.
Okay. And the last thing, and then we'll be done, is for things that you can't find there, have you ever heard of McMaster Car?
Yeah.
Okay, so McMaster Car that's where you go to find everything that you didn't find on these other sites. They have literally everything is here. You just have to go find it. So for example, if I needed what if I needed we'll go find a bearing, right? If I need a bearing.
So how do we know like these are not these are like the parts that you can use in FTC versus not using FTC?
There are very few parts that you cannot use. You can't add anything that is electrical, needs to be on the approved list. Generally, almost anything mechanical you can put on. So, and especially bearings and fasteners and springs and all that stuff, it's pretty much fair game. Anything that's complicated, you're not really allowed to buy things in FTC that are very complex mechanisms. So you can't put on LiDAR or you can't put on anything that seems overly complex. And you can check the rules for that, but pretty much all basic stuff is there. You should be able to use it. So here's the thing about McMaster Car, a lot of people don't realize. And so let's go find oil impregnated sleeve bearings and I'll just just going to pick one 3/16 shaft, right? So here, when I go to buy one, if you look on this little thing, so let's say you found one, a thing on McMaster car, and when you click on its part number, it'll bring you this up, and there's the little order page. If you look under product detail, oh, actually, they even made it better. You can actually download the 3D step file for it right here. And so that's super nice if you don't have a model for something, even if you don't buy it from McMaster car. A lot of this stuff is just sort of like industry standard size.
Try it out in CAD and then decide to buy it or not. Right?
Yeah.
Yeah.
And you can also, if you need, the nice thing about product detail on McMaster cars, when you click on it, it'll actually give you, like, this is a very simple part, but it gives you the basic dimensions on how to draw the thing. It'll also give you a 2D, you can also download a PDF of the thing, but you can also do these CAD formats. You can get it for SolidWorks, and step file is the baseline. Everybody can import a step file. Almost every CAD program imports step files. It's ancient. They haven't updated it since 1996. But it's so standard that they don't dare. So all programs that you're going to work with can import a step file.
Excuse me?
Yeah.
I have a few commitments here at home, such as chores and cooking and stuff such as that. So I'm going to pop off.
See you next time. Keep an eye out for a time change. I think we're going to change the time for next week.
Okay. Also, I think only after I leave, only Anand will be here. Everyone else just left.
Not a problem. They all had to go. No worries.
Yeah.
See you, man. Bye.
So will you send an email about the time change?
Yeah. I need to verify the schedule. We have lots of meetings on Tuesdays. I just need to look at my calendar to make sure I don't take. I like to do these the same time every day because the kids they're not very inventive about keeping up on schedule changes. So. But yeah, we'll try. I think we'll probably try for 5 or 5:30. I just need to look to see how it goes. So anyway, so there's a basic tour for the universe on that. Was this helpful?
Yeah, super helpful. Like tons of information, and it always helps to talk to somebody with experience, and at least for new teams, right? To get some like people who have experience, they tell you things that rather than learning them from our own mistakes, it's just better to learn from somebody who has been there, done it, seen everything, right? And
I've screwed up so many times. Yeah, no worries. I 100% get it.
Our team will make lots of mistakes as well, but at least like getting to some basic point, that's super helpful.
If you can get them to the point where they can drive stuff around, that's when the magic starts to happen, because they start to see possibilities. And so I'm very encouraged that you have got them working on that. Is this a home-based team or a school-based team?
Yeah, home-based team. So there are kids from various different schools.
Sure, sure. Well, a lot of our best teams are home-based. So that's outstanding. We welcome you. And all right, are you going to go to the kickoff in Auburn, or are you going to do the virtual one?
Virtual one.
Okay. Well, you'll see me again. You may or may not know actually who I am. I'm Kevin Ross. I am the founding chairman of First Washington, and this is my 22nd year doing this.
Yeah, I read your bio in the email.
Oh, you did? Okay.
Yes. So I was like super excited to join this meeting.
Well, good. Yeah. And please invite your kids. And if there's anything I can do to make it easier for your kids to attend, that's our goal. That's our goal. So, because I see that my kids didn't make it. I've got a couple of emails from them saying that they didn't get home from school until just about 35 minutes ago. So they said there was no point joining. So obviously I got the time frame wrong. So we'll modify that.
Yeah. So
All right.
I should wait from first to get the email about the recording as well as the time update.
Yeah, actually, why don't you in the let me stop sharing here. So in the chat,
Can I give you my email address?
yeah, there's mine. All right, and let me grab that, and I'll upload this right away. And there you go. In fact, I'm going to stop the recording.